Welcome to Study Loop.
In this problem, we have a simply supported beam AB with a uniformly distributed load and two unknown loads, P and Q. We're given the values of the moment at points D and E, and we want to solve for the unknown applied loads P and Q and draw the shear and bending moment diagrams. What we're going to do here is we're going to look at three segments of the beam to find shear forces, unknown forces P and Q, and reaction forces A and B, and then we can draw the shear and bending moment diagrams. So first we're going to look at DE. All right, we are going to have our two moments that we were given. So we'll have our 5,500 at E and our 6,100 at D. We're going to have the shears at each point, VE and V at D, and we'll have our resultant uniform load, and that will be at the center. Okay, we can sum our moments and set equal to 0. So we'll take that at point E, and we're going to get a 5,500. We're going to get a 1,000 from the resultant with an arm of 2. Subtract the 6,100 at point D and subtract the shear at D times the arm of 4, and setting that equal to 0 and solving that for V. We get the shear at D equals to 350 pounds. And now for this segment, we will sum the forces, the vertical direction, and set to 0. So we've got a 350 for V sub D minus our 1,000 and plus a V sub E equal to 0. And if we solve that for VE, we get V equal to a minus 650. And we can check those on our shear diagram. Okay, next we're going to do segment EB. I'm sorry, we're going to do next we'll do segment AD. Let's do AD next. And then we'll do EB. All right, so looking at our segment AD. So we're going to have our shear at our moment at D, 6,100. We're going to have our shear at D, 350. And we're going to have our reaction at A, and our result. So we'll have our resultant of 1,000, and we'll also have our unknown of P here. All right, so for segment AD, we'll sum the moments and set to 0 about point A. And we're going to have a 6,100. We'll have our 350 from shear at D. We'll have 1000 from the resultant, an arm of 2, and we'll have minus 2p. And setting that equal to 0, and we solve for p equals to 1,350 pounds. And now we'll sum our forces in the vertical direction and set to 0. We've got reaction at A minus 1,000 minus our P of 1350 and minus a 350. Setting that equal to 0, and that gives us our reaction at A equal to 2,700 pounds. And our third segment will be segment EB. And we're going to have here, we'll have at point E, we'll have the moment 5,500. We'll have the shear at E, 650. At the other end, we'll have the reaction at B. We'll have our resultant from our uniform load and our unknown Q. All right, we're going to sum the moments and set to 0. And we will do that around point B. And we've got a minus 5,500. We've got the 650 with an arm of 4. We've got the 1,000 with an arm of 2. And we've got the unknown Q with an arm of 2. All right, and if we solve that for Q, we get Q equals to 450. And next we can sum forces in the y direction and set to 0. We've got reaction at B minus a 450 minus a 1,000 minus a 650, and setting that equal to 0 gives us reaction at B equal to 2,100 pounds. Okay, we can use all of this information to draw our shear and bending moment diagrams. And so we'll have our V, and we'll have our M. All right, so for our V of X, we found, scrolling back up, we found reaction at A was 2,700. So we're going to start at 2,700. Right, it's going to slope down until we get to point P. And then we're going to have reaction, the force of P. And we'll slope down again until we get to Q. And then until we get to our reaction at B. Okay, let's find these points. Let's see. So we've got, this is going to be 2 and 2,200. This point here is going to be 2 and 850. We're going to cross our axis at 5.4. We're going to have this point 10 and minus 1,150. I have 10 minus 1,600 and 12 and minus 2,100. All right, if we look at the areas, and divide up these regions. Okay, this rectangle here is going to be 4,400. This rectangle is going to be minus 3,200. This triangle here is 500. This triangle here is minus 2,645. And this triangle here, minus 500. All right, now we can use these areas to draw our bending moment diagram. So what we'll have is a parabola with some changes in slope. So we'll start off here, and we'll have a decrease in the slope of the parabola, and then we'll have our maximum where our v becomes negative, and then our parabola becoming negative and changing slope. Okay, and our maximum here for our parabola occurs at 5.4 and a value of 6,345. So we get, for our final answers, we've got P is 1,350 pounds, Q is 450 pounds, and our max shear is going to be 2,700 pounds at our point A, and our maximum moment is going to be 6,345 feet, and that's going to be at 5.4 feet.